domain is what? The x values, and range is the y values. So I want to know what all of the x values on this graph have. Well, that's why we learned some new notations in the last couple of days, because do you really want to list every x value on that graph? No. So we need to use some kind of notation. Probably interval notation. That's probably going to be our best bet. We could use set notation, but it would probably end up being harder to write set notation. So interval notation is going to end up being best. So what I'm going to do, this one, if you can't see it, it looks like this, and it should have arrows on the end, which we'll talk about that a little bit. So I'm going to take my pencil, and I'm going to put it on the left-hand side of this graph. I'm going to look left to right. And I'm going to ask myself, is there anywhere that this doesn't touch the graph? You do have to use your imagination, pretend it goes on forever. Am I touching the graph here?
What? Yeah.
Yeah, back here? Like all the way back here? How far back here? Negative infinity. So would you agree this graph starts back at negative infinity? And it keeps going, keeps going. Do I always touch? Always? So the domain of this function is negative infinity to infinity. It has all the x values. So now let's talk about the range. For range, I'm going to start my pencil the other way at the bottom of the graph. Am I touching the graph in here? No. No, 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 no. Where's the first place I touch that graph? At 0. Does it actually touch 0? No. So right after 0, right? How do you say right after 0 in interval notation?
Oh,
Almost. Not the bracket. The other one. The parenthesis. The parenthesis is the one that says all the way up to, but not quite there. So you were close. So almost to 0. Does that make sense? How that says almost to 0 to infinity. If 0 were included, you would put a bracket there. If it touched 0, you put a bracket. Yes. Always, yes. And the reason they do that mathematically is that you can't actually equal infinity. And so they always parentheses. Yes, if you can, depending on the problem. If it's just a graph, you just have to go with what you got. If it's an equation, we will put it. You'll see it's more examples. Okay, this one again. I'm gonna put some arrows on those. If they don't have arrows, I would have to take it both ways on whether you stopped it or you kept going. This one was originally had arrows there. And so I'm gonna look for domain and range. Okay, so I'm going to start at the very far left, and I do have to use my imagination a little bit. Am I touching this graph over here? Yes. Yes, look at the arrow, right? That keeps going, doesn't it? So I have to use my imagination a little bit. Okay, that's going over. Does it keep going? Yes, it does. So we're at the very far left x value. And then I'm going, but then right here I stop. Where is right here? -1. Make sure on domain you're using x values. We'll use y values on range. Let's stop at -1. It is an open circle. What does that mean? Does anyone remember? It's parentheses. Good. The open circle means not including. The filled in dot means, yeah, there's a point there, so I will include it. Any questions about that so far? Am I done? Is the graph over? No. I don't have anything from 2 to 1, but then at 1, don't I have more x values? Remember, I won't count off for not having the u, but u just says this set and this set. So I'm going to pick back up at 1 for x values for domain. Why did I put a bracket on that one? Because there's a dot there, so it actually actually, the x value of 1 is on the graph, filled in dot. I'm going to bracket that. So I'm going to go from 1 to. Is there still a point there?
Yes. Oh, so
Do I have to stop there?
No.
Does everyone see that? Even though there's a break, the graph, my x values don't quit. So I don't actually have to break that. I can keep going all the way to infinity. So the domain is all the x's from negative infinity to negative 1 and from 1 to infinity. You don't have to break it. Because of the closed dot, actually. If there were open dots on both of them, I would have to say, okay, 3 is not in the domain, and I'd have to stop it and say, there's no 3 there. But this goes all the way up to 3, but then that picks up right at 3, so I never lose any x values. So remember, this is all the x values that get touched, not that we don't have to worry about when it breaks or anything like that. It's just when I touch an x value. So I technically touched 3, so I have no need to break it.
And the reason why they do that is because I guess it's a function, so if you put a dot there.
Right. So if you have a function, if you have a dot in both places, it wouldn't be a function because your x values would repeat. Okay. So domain and range in this one. To be able to do this one, we're going to need some dots. Oh, sorry. Go back to the range. Good call. Okay, let's do the range. Thank you very much. Start at the bottom. Am I touching the graph at the bottom? Am I touching it here? 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 So I got the dots that kind of cover it. So yeah. Here? Here? All the way up to 6. Does that keep going up?
No.
Does this one go up? Nothing goes up. So I have to go negative infinity 6. Bracket or parenthesis on the 6. Parenthesis imply. Open circle on that 6. Good. I'm glad you asked that question. Because we needed to do that. Okay. Look at these two. Same thought process. On your homework, if there are not arrows, stop it. So I'm kind of putting arrows on, but on the homework there are arrows on the ones with arrows, and there are some that don't have arrows that stop. So work it correctly. On this one, it doesn't have arrows. It probably would on your homework, but let's, we'll pretend it stops. Sure. Because on your homework, like I said, if it doesn't have arrows, we're going to assume that it stops. The top one's closed, the bottom one's open. Okay, so what's the domain? Negative 5 to 5. And I do agree, it kind of looks like it might go on. Like I said, on your homework, they do put arrows on the ones that keep going, and they don't put arrows on the ones that don't. Since I just had to get these graphs off Google, I didn't have arrows on them. Good question. Since there's not an open circle here, I'm going to assume that it gets there, but I am making an assumption you will never be tested over that. If there's not an open or closed circle, I would have accepted either parentheses or brackets on the same size, because there's not a clear cut. Good question.
So a little confused about the
Yeah, since it doesn't have anything that indicates it continues ongoing, we're going to stop there. Again, your homework will have arrows on some, it won't have arrows on some. The ones that do have arrows keep going, and the ones that don't stop. Okay, on the heights there. Am I touching the graph down here?
No.
I am touching it right there at y equals -1. I've got it here, and then I'm touching it right there at y equals 1. Is interval notation a good choice if I only have two values? No. What's a better choice? Just say it. Is that what you said? Set. Yeah, set notation, or just say the values. The range on this problem is just -1 and 1. It's not a to and from thing. Like the range is just the numbers, -1 and 1. You don't want either, because parentheses and brackets would mean -1 to 1. So you just want to list them. And I use the little curly braces like a set. If you just left those off and just set the range as -1 and 1, it would be correct. But there are just two range values, and that's it. It's not a to and from thing. Remember, interval notation is to and from. This is from -5 all the way to 5. This is just the numbers, -1 and 1. So that one was a tricky range, and I wanted to do that one. This one will have arrows on. Again, your homework will either have them or they won't. You don't have to put them. They're there on some and they're not on some. This one we're going to have arrows. Okay, so if it does have an arrow, what do I have to think when I'm looking to the left? That it does continue on, so we've got the domain would be -infinity. Does it stop? No, why not?
The two dots.
The filled in dot ends here, so 2 is included, so I just keep going all the way to infinity. So my domain is -infinity to infinity. And what about my range? -infinity to infinity. Probably would be nice if you could definitely tell that was at 1, but it looks like it is. So -infinity to infinity for the range. Everyone see how we're going to do that on the, we're going to take our pencil at the bottom and work out. Take our pencil at the left and work it right. Circle back. This way. Yeah. Where? This one. On the bottom, the range. Okay, let's see how this levels off right here. Yeah, it's an exponential function. It doesn't go full like that, but the way that they do that, where it doesn't, if they were drawing it currently on down, they would go ahead and cross this into the front half. That makes sense. This one, they've got it kind of staying straight. That makes sense. Okay. Now we want to talk about functions graphically. Now we talked about what was a function yesterday, and now we need to talk a little bit about what's a function today using graphs. James already kind of gave us some insight into this. He said if you had two filled-in dots on top of each other, you wouldn't have a function. Would agree? Because your x values. So graphically, to find out if something is a function or not, we're going to use what's called the vertical line test. So write that down, vertical line test. We are going to take a vertical line along the graph. If it ever touches in more than one place, it's not a function because the x values are fixed. If it doesn't ever touch in more than one place, then it is a function. So if I look at this one, do I ever touch in more than one place with the vertical line? Let me draw one for people that's watching on video at home. And if I take a vertical line, do I touch twice sometimes? Yes, bunch of times, right? So this is not a function because I touch more than one time. It fails the vertical line test. only hits one time. That makes sense. This one is a function. You could either say the x values don't repeat, or you can say passes the vertical line test. Either way. It did go ahead and ask me to state the domain and range, and if the interval is open or closed. And we'll talk about that. Here we go. On this circle, let's do the domain and range on the circle. On this circle, from here to here, what is the domain? And I'm going to steal my line so people at home can see what I'm doing if you're watching on video. So I'm going to look from the left. Am I touching? But I'm not out here, right? So the first place I touch is right here. You can't see that, but it's -1. You can't see that tick mark and what it's labeled, but it's -1. So from -1 all the way to +1. And both of those on a circle, even though they aren't filled in, it actually touches those on a circle. Those two steps will be bracketed -1 to 1. So that's the domain. It asks, is that an open or closed interval? And it's kind of a weird question, but the ones with brackets are closed intervals, and the ones with parentheses are open intervals. Kind of think of it with the open circle and the closed circle. The brackets are closed intervals, and the parentheses are open intervals. So that's a closed interval. And then the range is also going to be -1 to 1. So this time I'm going to take my line and make it a horizontal line. Right? Doesn't touch at the bottom, starts at 1, all the way up to 1. Any questions? Then it's neither open nor closed. It's active. Hopefully they don't ask a question. You can say that. Say it's either open or closed. Or you can say the left side is closed and the right side. Okay, the range, I'm going to do that first. So my line's horizontal. Start at the bottom. Doesn't touch. Where's the first place it touches? At 0, and it does touch 0. The ones that don't touch, if they don't have the open circle, are the ones that are asymptotes. Have y'all heard that word before? They get really close to the line but don't touch it. We'll talk more about those. Good. 0 to infinity is the range. And the domain is -infinity to infinity. Any questions about that one? Okay. Last slide. The same question, they just don't give us a graph. You obviously are not expected to graph these by hand. So what are we going to do? We're going to make a graph in our calculator. So get your calculators out. We're going to graph these in our calculator. We're going to do the same thing with the calculator. And create the opportunity to do that. Not right. And in fact, you will never be able to do that calculator in this class. Different AP opportunities are preparing for AP calculus. Half of the AP exam is on a calculator. In this class, you're preparing for the college algebra final and the ACT, and both of those are completely calculated. So it's kind of a different game. Okay, so graph this top one in your calculator. Does everyone know where to get the square root button? Everyone know how to get the square root button? Math. So it looks like this. Everyone got it in your calculator? Okay, I'll wait. No problem. because we aren't given a graph, but with a calculator, this becomes the exact same question from the last slide. I'm going to look, what is my first x value? -2. Now, the cool thing about having a graph on a calculator is you can tell if -2 is in the domain or not. You can plug in -2. If you get a number, then it's in the domain. So if you were unsure if it touched at -2, you try it. If you plug in -2, you get 0, it's a point. Just a random thought that doesn't have to do with what we're doing today. Why would these numbers out here not be in the domain? Why can we not plug in a -3 for x? Why not? What's -3 plus 2? -1, right? What's the square root of -1? Not a real number, right? And so that's why that's not in the domain, because it doesn't work. It's a random thought, you don't need to know that today, but we'll talk about that in a minute. So -2 is where does it go to? Infinity. So that's the domain. Any questions about the domain? What is the range? 0, does everyone agree the first y value, if I start at the bottom, right, now walk that, I start the line at the bottom and walk that line up. The first y value I hit is y to 0. That goes on to infinity. Okay, graph the next one. If you don't know how to get to the absolute value bars, there's a couple of ways to do it. My favorite way is to push second 0, which is your catalog. Everything is listed in alphabetical order there. The reason I like that one is because absolute value is the first thing on the list. Maybe second 0, and push enter, and that'll give you the absolute value bars. If you didn't know how to find them, that's the way. There are other ways to find them. If there's anything in your calculator you are looking for, second 0 has everything in alphabetical order. Symbols are above A. So if you're ever looking for something that you can't find, you go there. You don't have to show the picture, but you'll have to graph it to be able to insert it, but you don't have to draw it. I think that's how the worksheet is set up. It's today's worksheet. Hey, g of x, absolute value of x minus 2 plus 3. Yeah. Minus 2 plus 3 gives it. Oh, thank you, Laura. Your windows are different. So you're just counting by different things. The graphs are the same. That makes sense. Okay, did you get something that looks like that? Sort of. Okay, let's talk about domain first. Does this keep going? It does. And if you're unsure, just trace it. Go back and see if it keeps going. It does. So negative infinity to infinity for the domain. What about the range? Three is my first y value. On up to infinity. 3 to infinity. Positive 3 to infinity. Now, if you can't tell where that bottom point is, use your trace button. Does everyone know where that trace button is? And go on. Remember, you will be looking for the y value of that point. If you're looking for range, if you're looking at domain, you'll be looking at the x value. Okay, one more. This one looks something like this. Try it. You graph it. touches the 2. Looks like it gets really, really close, but doesn't touch the 2. So we're going to have to leave the 2 out of the domain. Is everybody agree? In fact, one way to say this is to use set notation and say x is all real numbers except 2. Since we're using interval notation, I'm going to go ahead and do interval notation. Starting at negative infinity, I go all the way up to 2, but I don't get there. How do I show that I go all the way up to 2, but I don't get there? You see how this never gets to 2? It goes straight up and straight down. It just never gets to 2. So I go all the way up to 2, but I never get there. And then on the other side, don't I go all the way up to 2, but never get there on the other side? So the domain of this is everything but 2. And to write that in interval notation, that's how you write it. This one was a tough one because it's kind of hard to see that graphically. You will have one on your homework that's identical to this, just with different numbers. I know if you see that shape, you're going to leave something out of that domain. And then let's talk about range. Do you agree it looks like it gets really close to 1, but never gets to 1? From negative infinity to 1 to infinity. So again, that one's the toughest of the domain range problems as far as the calculus. Any questions about that? Okay, you have 10 minutes, or no, 15 minutes left in class. Use it. 10, no, you have 2 minutes. Go ahead and do a problem. Do one extra, you know what you're doing. There are 2 different questions that are asked for somebody range. Something range and there's function. Remember, function is not a I was up until 3 o'clock doing all my work.